we're going to take a look at the inverse tan of x. So let's say we have f of x equals the inverse tan of 6 over x. We want to find f dash of x. Alright, well, the log tables tell us that when I differentiate inverse tan of x over a, I get a over a squared plus x squared. Now, that's very, very rarely actually useful. That's what's in the log tables, but it's very rarely what I use. Usually what we use is, we use this, but we make a 1. So this you can only use if you have x over 2, x over 3, x over 4, x over a number. That's not what I have. I have a number over x which is different, so I can't use this. So what I do is I'm going to rewrite this, but I'm going to make a 1. So if I make a 1, I get the inverse, I get 1 over 1 plus x squared. And this is the formula that I'm going to use. This, along with the chain rule, are going to help me do the question. So f dash x, when I differentiate inverse tan of a number, I get 1 over 1 plus that number squared. That's the first bit. And I have to multiply by the derivative of that number. There's two ways of differentiating that number. What we might do now is we might do u over v. So u equals 6, so du dx equals 0. v equals x, dv dx equals 1. And we're going to fill these in to the quotient rule. So we're going to get v times du dx minus u times dv dx all over v squared. So this is 1 all over 1 plus, let's square this, so 36 over x squared. And we're multiplying this by v, so x times 0 minus 6 times 1 all over x squared. So that's 1 over 1 plus 36 over x squared times, now that's just 0, so you have minus 6 over x squared. Alright, you might have spotted that when you want to differentiate 6 over x, you can write that as 6 times x to the minus 1, and you can get here a lot quicker. If you don't spot it, there's no problem, just do the quotient rule. Just be careful that you remember that when you differentiate a constant, you get 0. Alright, so what we're going to do, we'll multiply the top by the top, the bottom by the bottom, so we get minus 6 on the top. X squared by 1 gives me x squared. X squared by this thing, the x squareds cancel, so I get plus 36. And that there is the answer. Okay, so differentiate inverse tan. If you're asked to differentiate the inverse tan of, we'll say, x over 3, or x over 5, or x over 7, use the formula in the log tables. For anything else, anything that's not of that form, use this version, make a 1, right, rewrite it out, use this version, and then multiply by the derivative of the angle. Okay, so use the chain rule.